Some of you guys have already spotted that I don't have the Victron Lynx Shunt installed anymore and have bridged these Lynx Peter, the I can't say this word, and the Lynx Power In with some cables in between only. And the reason was the Lynx Shunt actually was faulty and I had to send it back for warranty repairs and replacement. It's always when you come into the garage here, you can see all the lights blinking and flashing, and somehow it caught my eye that these lights were not on anymore, neither from the Lynx Peter nor from the Lynx Shunt. I think there was a green light and there were some red lights. So basically all the fuses you haven't installed have a red light, and only if the fuse is okay, the light is off. So it basically tells you when a fuse has blown in this device. So there were always some green and red lights in this area, and one morning, well, no lights anymore. So I did some testing and now the Multiplus is coming back. Charging my wife's vehicle at the moment. And we have this mixed cloud situation here. Sometimes a bit of a shower, sometimes the sun comes back like this. Super bright sky. So the charging speed of the vehicle is actually going up and down. So will the controller inside the Multiplus control the fan speed as well. So you have to excuse the noise sometimes. Guys, welcome back to the off-grid garage here in sunny... No, it's not. You have seen the weather. It is not sunny at the moment. But we are still making... Well, I'm charging the vehicle with 15 amps, full power. And we still have 27 amps outside. Battery is charged to 73%. All good. Plenty of power now, even in these conditions. Well guys, anyway, welcome back to the show. I sent this Lynx Shunt actually back for repairs. Yeah, they sent me a brand new one as a replacement. Because most of the Victron gear comes with 5 years warranty anyway. And this was only close to 1.5 to 2 years old. So they replaced it under warranty. It actually took a while because I had to send it back to the place where I bought it in Sydney, and they had then negotiated with Victron what to do with the device, and eventually they sent a new one, replacement part. And I wasn't quite sure if I just should sell this one because the experience so far with this device is not as great as it should be maybe. And then I read all these comments under my videos where people discovered that I had that I had this bridge in between here, and I thought, well, it's probably actually worth reinstalling the Lynx Shunt and retest it, revisit it, and see if the new firmware update actually brought any improvement with this device, because, well, you will see later. Hopefully you won't see later, but we have tested this device before, and for the price you are paying, it is actually not providing a lot of good features. I would rather stick with the Smart Shunt than with the Lynx Shunt for the moment. But maybe this has changed, so let's find out. I think the QSO battery here has fully charged by now. Yeah, we are at 55 volts, 0 amps going in. You can see the yellow light there on the solar charge controller. So we probably want to turn the solar off. Also want to turn off the battery. So we should have no voltage on the bus bars anymore here. Let's check this. Okay, negative, positive here, 1.3. Doesn't make a difference. 1.3 volts we still have. That's fine. Oh no! Now the Multiplus has started the Phoenix inverter as well, because we are drawing so much power charging the vehicle, and maybe a pump has turned on or something. So we will have double fan noise here in this area now. But it's not too bad, right? Okay, no power on the 48 volt system anymore. Let's remove these cables. So we don't need to remove the cover for the Peter. These are exposed. Just loosening these ones here. God, jeez. Scared the shit out of me when these inverters turn off and on. It's when I undid these screws and then the inverter turned off. With a loud bang, you could hear the contactor turning off. Oh, that scares. Alright, so this is the quick installation guide. It's a brand new device. It even comes with the CAN terminators, temperature sensor, and there's a brand new Lynx Shunt in here. Sticker if you install the Lynx upside down. This, see, there it starts already. Quick installation guide, and it only tells you that there's a sticker inside the box. If you install it upside down, you have to put the sticker on, otherwise the writing is upside down as well. This is the whole purpose of this. Well, this is already quite useless, right? Okay, take this cover off. It basically still looks the same as the old one. So obviously you've got the shunt down here. It's a 1000 amp shunt. You can see it there. And this is where they measure the voltage drop across the shunt and then calculate the current. This. And up here you're supposed to install a fuse in between these two terminals. And someone sent me this CNN 325 amp fuse here. This is the original Victron fuse for this device. It's 80 volt DC rated and 325 amps. I think it was Rob from Germany, I think. Thank you very much, Rob, or whoever sent me this one. I mean, this is an $80 fuse, right? This is not cheap. So thank you very much. Before I had this, I had a simple A and L fuse connected to it. That's the same footprint and it will fit perfectly. They are not really rated for 48 volt systems. They're only 32 volts, I think. But I wasn't too concerned about it. It was just for testing purposes anyway. But now we can install the original fuse here in this location. Then washer, spring washer, nut. So, and now I don't know what torque I should use for this fuse here. And I was expecting that there's some information in this quick installation guide, but not how to install the sticker. That is useless. Okay, I just use, that's probably, I don't know. Come on, Victron, put some useful information in this quick installation guide, like torque settings for the terminal connections here and also the fuse. But not how to install the sticker. Okay, remove these two. Okay, here in the manual it says with M8 models 14 Newton meters for the terminals. Okay, let's put this back in. Oh, no way. I have to lift the Lynx Peter as well, otherwise I can't get the bolts underneath. So we do have to remove the cover of the Lynx Peter. Okay, let's see, we are down here. Okay. And here on the other side, it sits on top. Okay. And then here again, washer, spring washer, nut. And then apparently you torque them with 14 Newton meters. Alright, and this concludes the replacement of the Lynx Shunt. It's not a smart shunt, it's just a shunt. So we've got our batteries here on this side and the solar and loads on the other side in the Lynx Peter. And in between is the shunt measuring power going in and out of the batteries. And as you can see, the Lynx power in has some fuses for each of the batteries as well. There is some slight modification necessary to the actual Lynx power in. And then you can install fuses as well, pretty much the same way as in the Lynx Peter. I made a whole bunch of videos about these devices here. I'll link them all down below. It's actually a pretty cool system. I just don't like the shunt. But hopefully with the new firmware now, everything is fine, everything works. So fingers crossed. So I've got my yellow CAN cable for the Lynx Shunt. And obviously in the second port belongs this terminator, which is in the box as well. And then this yellow cable here goes directly to the Servo GX, and this connects to the VE CAN port. These are all CAN communication devices from Victron, and you can daisy chain them. I think I've got, yeah, these ones up there. These ones have CAN port, see that? There. CAN port, CAN port. They don't have CAN port communication. I don't use it. I use VE direct communication from the MPPT solar charge controllers to the servo or to the Raspberry Pi in this case. If you have very long runs between your MPPT solar charge controllers and your Servo GX, obviously CAN communication is better. You can have cables in between up to 100 meters, and I think the VE Direct is limited to only 10 meters. Here it is only 1.52 meters or something until it reaches the Raspberry Pi running the Venus OS. So we can plug this in here, put the terminator in the other port up there, and there's another communication port here which connects the Lynx distributor with the shunt. And I believe this one plugs in here. So there's actually a communication happening between the Lynx speeder and the Lynx shunt. If one of the fuses blows, you will get a message on your device through the Servo GX. So this is what this cable is for. Alright, let's close the covers and then we can see if it works. And more importantly, how it works. Nice and clean setup. I really like these devices. It's a 1000 amp bus bar inside and a 1000 amp shunt now. So you can really build a very powerful and good looking system with these devices. Alright, let's turn on the battery again and see how it works. 3, 2, 1. Okay, BMS is on. Here we go. Here we've got lights. This one is booting up now. Solid green running. This one has power. See, these were the LEDs I always saw, and then one morning nothing anymore. So because we have already established the CAN communication here, we should see the Lynx shunt actually popping up in the Victron system already. Alright, so I'm already logged into my tablet here. We go to the remote console of the SBAT calibration center. Go into settings. And yes, it pops up already. Lynx shunt. There it is. Okay, relay state, alarm state, state of charge. Nothing is set up so far. Settings. Battery bank. 200 ampere hours charge voltage. Whoa. So I'm setting this one here to 55 volts, the same as for the Smart Shunt. Okay, and we do a tail current of 4%. I can put this down to 2%. So that means up here 200 ampere hours for the battery. 1% would be 2 amps and 2% would be 4 amps. So it needs to reach 55 volts, 4 amps for 3 minutes, and then it resets to 100%. Pure good component, we set this one to 1.00. So no effect. And the charge efficiency factor, we set this one to 100. Oh, it can only go to 99. Oh, all right. Yeah, someone said this recently in the comments that he has good experience to set the pure good exponent to 1 and the charge efficiency factor to 100%. And the Smart Shunt is apparently very, very accurate then. So I'm testing this right now. I'm not sure if it actually works, but here we can only go to 99% for some reason. And here we've got the current thresholds. It's on 10 milliamps. So everything under 10 milliamps will not be recognized and counted by the Smart Shunt, or the Lynx Shunt in this case. This is for the average calculation. That's all fine. Press to sync to 100%. Yep, we can do that. Battery is fully charged. Calibrate 0 current. Yep, we can do this as well. There's no current flowing at the moment. This is our 0 point. Alright, that's all we need at the moment. Then obviously you can go into alarms here as well and set different thresholds for low state of charge, high state of charge, and I think also battery voltage. Yes, battery voltage as well. And then it uses the internal relays, as well as it sends you messages on your mobile device as well through the Servo GX. So I'm not using this at the moment here, but it is possible. So we should see 100% state of charge, consumed ampere hours 0. That is all cool now. So the only thing we need to do now is go into settings and go into system setup and set our battery monitor from the internal BMS in this battery here to the Lynx Shunt. Boom. Has DC system? Yes. Controlling BMS, the JK inverter BMS. It's not the JK, it's the Tangalu Jiangbangda BMS in the QSO battery here. Works fine with Victron and Pylon Tech, but the name just says here JK inverter BMS, which it isn't. Alright, this is basically everything we need to do. And now we can test it. Let's turn on our solar as well. I don't think we'll actually charge, because as we have seen before, the battery is already at 54.3 volts, so it already charged. There will be a small current going in, I think. 2.4 amps now, 3.6, 3.7. So I can measure 3.33 amps, and the Lynx Shunt shows us 4.1 amps to 3.3 amps measured. Let's have a look what the battery shows. This shows us 4 amps here as well. 4.1 amps. Now we've got 4.2 amps here and 3.4 amps measured. Hang on, I'm measuring negative. Let's go into this path because it shows less. Yeah, that's much better. 4.27 amps, 4.25 amps, 4.3, 4.2 here. So 4.4 amps, 4.4 amps. So they are actually the same now. Noise. Yeah, this unity clamp meter is actually not as precise if it measures a negative current with the clamp. So when you're measuring current with the clamp, you have to pay attention on the current direction as well. If it shows negative, it measures not as precise as if the current is positive. Yeah, it's just a bit of a setback with these devices here. They are cheap. So what we need to do is use this changeover switch here and change the Phoenix inverter from the battery shelf, where it sits right now, to 0 to the Lynx system now. So this will turn on now and uses power from this battery here. But I have not plugged in the VE direct cable for the Phoenix inverter. So it will draw this power now as a DC system, right? I'll show you. Alright, here we can see the SPED calibration center now, and the Phoenix inverter is running at the moment, but you can see there's no AC load because the VE direct cable is not connected, so the servo does not know it is actually an inverter. It can only see that we are pulling 1.6 kilowatt, so it's a DC load at the moment, right? And previously the Lynx Shunt was not able to show us any DC load at all. Down here in this graph it only showed the AC load as a consumption, but DC load as right now was not calculated in and not shown as the consumption. It is now 12:30 and these two bars here should show us the consumption and the production between 12 and 1 p.m. I can only see the yellow one, the solar production, but not a consumption. So let's get this running here for 10 minutes and then we have another look and see if it actually shows a red bar for the 1.4 kilowatt we are using as a DC power. We haven't checked on the firmware yet. I just wanted to see if there's any difference so far and show you what the actual problem is. So while we keep checking here the DC load and consumption, we want to go to device list and firmware update and let the servo now scan all the connected devices and see if there is any new firmware available. There might be one for the Lynx Shunt. Let's see. Yes, there is one. So installed is version 1.08 and the new version is the 1.1 update device. So I can conveniently do this here through the Victron VRM and it updates all my devices and keeps them up to date. So uploading firmware to the GX device. I want to have a look if there's any sign. It is flashing. So I think that's the sign. We are updating the firmware on it. Oh, there's already success. Okay, that went very quick. Alrighty, so it does a rescan now of all the devices. There we go. 1.1 is now installed. Okay, let's go back to our dashboard and see if it makes any difference. Oh, it actually has lost track now of the state of charge. Press to sync. I cannot enter a number here for the state of charge. I can only reset it to 100%. So if I know the state of charge of the battery, I can set exactly this number into the Victron Smart Shunt, but not in the Lynx Shunt. Okay, so obviously it shows now a false state of charge, but that's fine, it will reset eventually. More importantly is there a red bar coming up after a while? So we are charging now for 6, 7, 8 minutes or so and no red bar, no DC load is being calculated as the consumption, which makes this shunt absolutely useless. Okay, let's give it another 10-15 minutes with the new firmware now. Maybe there's something coming up. So let's keep discharging with DC power and see what's going on. Alright, we are now using DC power for 15 minutes and you can see the solar bar has actually increased quite a lot. But next to it there's no red bar, there's no consumption. The Lynx Shunt does not factor in any DC power at all. Nothing, right? Nothing! Next experiment would be to plug in the VE direct cable of the Phoenix inverter into the Servo GX. There we go. That's it. And this should now shift all the power from DC to AC, because now the system sees we have a Phoenix inverter connected, which uses close to 2 kilowatt. And now you can see it has shifted from DC to AC. And I think now we will see the red bar coming up because now it's a known inverter for the system. And you can also see we are still using a bit of DC power here, right? And DC power is not really measured in the Victron system. It is a calculated value. All the power from the battery and the solar system should be going into the inverter, right? But there's always a bit of delay when these things are measured and calculated. So there's always a bit of slack, of drift in these calculations, and here it shows us 88, 100, 50, 120 watts. So everything coming from the battery and the solar, which is not being used by the AC loads, it assumes it is an unknown DC load. So DC power in the Victron system is only a calculated value. Okay, let's give it a few minutes and hopefully we see a red bar here calculating now the AC power into our consumption graph. Alright, so it is another 10 minutes later. We have used lots of power with the Phoenix inverter as an AC load now. And looking down here into the graph, we can still not see any consumption, right? It does not factor in the Phoenix inverter as a known AC load either. Even it shows it up here, AC load does not work. So, last test we want to do is turn off the DC. Where do I do that? Settings, system setup, has DC system. We turn this one off and tell the system, well, we only have an inverter connected. There's nothing else directly connected to the battery, no DC power, nothing. Yeah. So this is what most people have: battery, solar, inverter. Yeah. There's nothing directly connected. Okay, 10 minutes later, start the clock. All right, after another 7-8 minutes now, we can see we've got a new bar here because it's after 1 p.m. now, and the solar production shows, but not the consumption either. So even with has DC system turned off in the settings, we are still not calculating any consumption here in the Victron VIM. Even we are discharging the battery with 2 kilowatts here. And looking in the remote console, we can see the Smart Phoenix inverter, 2.1 kilo VA, but the Lynx Shunt just ignores it. And this is exactly what it makes so mind-blowing, you know? It is a Victron inverter connected to a Victron system and a Victron Shunt. And the Shunt does not factor in the Victron inverter at all in the consumption part. For whatever reason. Neither as DC nor as AC, nothing. It ignores it altogether. It potentially works when you connect a Multiplus or Quattro or any other VE bus system, but certainly not a VE direct inverter or a DC inverter. So any other inverter, a non-Victron inverter, will be totally ignored by the Lynx Shunt. And this makes the Lynx Shunt the most useless part in their product list. And this is why people refer to the Lynx Shunt as a useless and very expensive fuse holder. Because this is quite frankly the only thing it does. It carries this very expensive fuse now inside. This is all it does. All the other data we are getting into the VIM is completely useless. Victron, what are you doing? I was really hoping this one is fixed and the new firmware fixes it, but no, you're still ignoring your own devices connected to a Servo GX. What a shame. And I was hoping to use the Lynx Shunt actually for our upgrade here in the battery and system room. So that's why I decided to unpack this brand new device and install it, revisit it, retest it, and just to be disappointed again. And the funny thing is, if you replace this one with a Victron Smart Shunt, everything works beautifully. It calculates AC, it calculates DC, both together, shows this as a consumption graph in the Victron VRM, no issues at all. But this device, which is far more expensive than a Smart Shunt, just doesn't do it. The software can't do it, can't handle it. And a lot of people have complained about this with Victron, and they just say, you know, DC power is not as accurate, it's a calculated number, and we don't want to use it anymore in the Lynx Shunt, so we refuse to upgrade the firmware to make it actually work. Totally stupid in my opinion. So yeah, I probably put this one back in the box. It's still a brand new device. It has been used now for a couple of minutes, and sell this as a demo model or something. So if someone is interested in the Lynx Shunt, Victron Lynx Shunt 1000 amp shunt, get in contact with me and we can figure something out. Alright my friends, as always, thank you so much for watching. Thanks for all your amazing support. Welcome to all the new subscribers. I haven't got the number. Wow, we've got 96,088. That'll do. I've got only 1.8. Guys, thank you so much. And welcome to the channel, of course. As always, the reminder, guys, please do not send me any emails with requests and questions and everything. Leave all your stuff down under the videos. That's where I read. That's where other people read. They can help you out. They are interested in these questions and answers as well. So please don't send me any emails. I'm getting far too many. I'm unable to read them all. And I'm certainly not able to respond to them anymore. And as always, a very special thanks goes to the people who are donating to the channel here, buying me a beer, there you go, so I can calibrate solar panels, or becoming a channel member here. There will be a new channel member video coming out very soon. It is a members only video, just a quick one, but very interesting, you will see. And some people click the thanks button under the videos, as well as leaving a comment, liking and sharing. This is all very, very much appreciated and makes these videos possible, as you know. Guys, until the next video when we do something different again, I think. Yeah, definitely don't want to deal with the Victron Lynx Shunt anymore. Until then, guys, you stay charged, stay safe, and thanks again for watching. See you then. Bye-bye. Yeah, exactly. Bye-bye, Lynx Shunt. Terrible.